Hello, I'm going to show you how to write a Java program that scores a bowling game. So this will be 10-pin bowling, and I'll be designing it in a way that uses test-driven design. So this is TDD like you mean it. So the rules for this are where you can only produce source code by refactoring test code. The first few tests are quite weird because you're effectively having your functionality inside your test, and only once you've got duplication can you refactor it out into something that looks a bit more like what you would expect. So let's just dive in. So in bowling, if we knock down one pin, we score 1 point. So I consider that one of the simplest things. So rolling one scores one. So by rolling one, I mean we're knocking one pin over. So we start with our assertion. We expect one, and we're going to we're just going to assert that our score is one. So start off being 0, and obviously it fails because score is 0 and it's not 1. So now we have to sort of simulate where the functionality that we desire. So this is rolling our ball. So when we run this, our code now passes, but we can't produce any source code because we haven't got anything to refactor out. So we move on to our next test case. So rolling 2 scores 2. Again, start at our assertion. We'll expect 2, and we're going to start introducing some duplication. I was going to write some code to make the test pass by accident, but no, you've got to see it fail first. So we expect 2 but not 0. So now we can go ahead and write some code to fix that. So rolling our ball. Okay, so both of these tests pass, but we've got duplication. For a start, I'm going to move score into a field for our inside our tests. Run the code. Passes. Let's get rid of that. Again, passes. Same in this test. Still passes. Now I'm going to have a method that does scoring for us. So this will be not scoring, but it rolls the ball for us. So we'll have a method called roll. So we run that, passes, but we want a parameter, otherwise it's completely useless. So parameter will be pins, number of pins we knock over, and we'll add that to our score. Run our tests, and they pass. Again, just because I made that change. Run the test again. Okay, so that passes. I'll get rid of that nasty comment. Run the test, still passes. And let's change all of this line to use our new roll method. Okay, so we've got some code that actually we're starting to see some emergent functionality, like this roll and this score. It doesn't really belong in our test code, so I think we can move this over to a source code folder. So to do this, we want to move this method to a class called game. To do this, we need a target. We need some sort of reference to a game object for us to be able to move it. So to do that, I'm going to change the method signature, and we're just going to pass in what's going to be game. This isn't declared yet, but we'll just go for it. So it's going to complain because game doesn't even exist. So if we declare that class in the source folder, we now have this, and we can run our code, just make sure I haven't broken anything. And we've now got a target, so we can actually move this over to game. If I'd tried to do this before, it wouldn't have had any move targets, but now it does, so I can move that over to game. This is quite ugly, I should say. There's probably a nicer way of doing it, but I can't think of it, so we'll just do it this way today, and I might redo this video showing better practices. In fact, the solution we're going to end up with is not particularly object orientated, so it's likely that I'll do a continuation where I refactor this solution into something that uses more objects. So we've got this horrendous deprecated method that that does some nasty stuff. So we're passing in null as a game, and then it runs the roll function on a game, but because we're passing in null, that's going to fail. So what we're going to have to do now is change this null to, well, we're going to have to declare a game. Oh, it shouldn't be private. Or should it? I don't know. We'll make it public at the moment. So we have a new game, and we just pass that in here. Oh, not there. Instead of the null. So our game. Let's run the tests. They still pass, so the code's still working, although it's not in a great state, obviously. So this is our game class. It changes the score inside bowling game tests, which is pretty bad, I gotta say. So we need to move this, and I'm pretty sure our refactoring doesn't work. We'll give it a go though. See what we end up with. So now we've got our score inside here, but we're still referencing it, so that doesn't make any sense. Okay, now we're referencing the right score. That does exist. But now we're trying to assert that 1 is equal to score, where score isn't a variable in this, well, it's not a field or a variable in the scope of bowling game tests, because we've moved it over to game. So let's have a function score that just returns our score, and then we'll replace that with game score. Likewise for that. So our code passes, but we've still got some more things to do. For example, this roll method's pretty horrendous. In fact, what I'll do first is refactor this method so we're no longer passing a reference of game into roll, as roll is a method of game. That makes no sense at all. Actually, no, we're not passing in a reference of game. We're passing in a reference of bowling game tests. That makes absolutely no sense because we're not touching anything in bowling game tests, and we shouldn't be. So change the method signature, remove that, and run a test. Okay, and now we want to use our game object and use the roll method on that. So I broke this because the roll method on game only takes one parameter. So if we change these, it now passes. So we can get rid of all of this code. Finally got something that looks a little more like something you'd expect. Now we can have a look whether we need to do any more refactoring. This looks reasonable to me. I'm not quite sure about having this game score repeated. I'm just going to leave it for the moment. If you have any ideas why it should be refactored out, I'd really like to hear that, because I'm not sure. This looks okay for the moment. I'm going to plough ahead and we'll see that we get some problems, so we'll have to come back and refactor this multiple times, but I think it's really important to see why that happens, and this is how Uncle Bob does it in his slides. So basically what I'm doing is a reproduction of his slides to some extent. All the credit goes to him, none to me. I'm useless at this sort of thing. Okay, maybe not useless. I'm doing myself somewhat of a disservice. Okay, no, we'll just move on. So we can continue rolling things and just scoring them, but that's pretty boring. Actually, in fact, I'm just going to get rid of this test and then save the code, run the code, make sure it all passes. This is not the simplest thing we could have. We could just assign score to the number of pins we knocked down. If I run that, the code will still pass. That's simpler than what we had before. So now we can write a new test that specifies the behavior of having, where we're adding the number of, where we're sort of incrementing score by the number of pins rather than just assigning the value of pins to score. So if we just rolling 1, then 1 scores 2, that specifies behavior we want. So if we have game roll, oh, I should have written my session first. So I'm just going to stick this in a for loop. Send to I++. So that will fail because we'll get 1 instead of 2. Now we've got a specification to have plus equals. Okay, code passes. We can move on to something more interesting now. So if we if we score a strike and then actually no, let's just spare first. That's a simpler case. So rolling a spare, then a 1 scores 12. So when you throw, when you score a spare, so that's where you knock down all the pins in 2 rolls, you get a bonus for doing this, and the bonus is the score of your next roll. So that means that we don't actually know when you've knocked over all your pins in one frame. So one frame has, you get 2 rolls per frame basically, and if you knock over all the pins in your frame, then that is called a spare. And when you get a spare, then the score for your spare is 10 plus the number of pins you knock down on your next roll. So we can't actually score our spare until we've rolled our next, the next part of the first roll of our next frame. The approach we're going to take is we're going to roll everything first, and then so we'll complete all our frames and then we'll score everything at the very end. So if we say we have a 5 and then roll another 5. Oh, again, should have done my assertion first. Very bad. Okay, so we'll roll a 1. Yeah. So if we run this, we're going to get 11, not 15. Yeah, 11. So that's 5 plus 5 plus 1. So we've got to change our code in some way to do this. But if you look, roll is basically, well, roll calculates our score. It's doing stuff to score rather than actually rolling something, and scores just a getter for this field score, which means that our responsibilities aren't really in the right place. Our score should be getting calculated in the score method, and roll should be recording our rolls. So what I'm going to do is comment out this test. We'll come back to it. We run our code, it passes, so we can now refactor. And I'm going to have oh, okay, this is returning something. Not quite sure why. We're not assigning it. We're not using that value at all. So I'm just taking that out. Run our test. Make sure that doesn't break anything. It doesn't. So we can go ahead and refactor more. So I'm going to have a field called roles, and it's going to have. We're also going to have a counter, our current roll, and we'll assign the number of pins we knock down each time to this. So let's have a field roles, and that's going to be a it's going to be an array of integers, 21 integers long. So in bowling, you have 10 frames, and each frame has two roles in it. So you would think you'd have an array of 20 integers. However, if you have a spare in your last, so if you just don't score any spares or strikes up until your last frame, you'll have rolled 18 times. In your last frame, if you get a spare, so you'll have rolled 20 times, you still roll an additional time to get the bonus for the spare, and the so that takes 21 rolls, which is why it's an array of 21 integers rather than just 20. So we're going to have a field current roll as well, and that'll be 0 initially, and we'll just increment it each time we roll. So score, we're going to have a for loop that does our score, that sort of sums up our score for us, which would be score plus equals, actually we can have equals, that's a simpler way of doing it, and it means that we have to write more tests to specify the behaviour you want, and we have a more complete test suite at the end, so that's a bonus rather than an aim of TDD. So TDD is meant to drive a design rather than just produce tests. That's a side effect, a very nice one, very handy, but that's not the goal of it. So we're going to want to just do that, I believe. So if we run our tests, they all fail, so evidently I've done something wrong. Expected 2 but was 0. Same for all of these. Exactly. So we do need a plus equals, because everything after the rolls we've rolled are going to be 0. So we'll just assign everything to 0 unless we roll something at the very end. So run our test again. They all pass. Okay, so this behaviour was specified, so it's nice to know our tests do pick up on that. I's a horrible name for a variable, so this is going to be our roll index. So let's run our test again. Still pass. So we can come back now. Okay, so we've got something that records our rolls and calculates our scores. So our behaviour, the responsibilities of each function, the functions do what they're supposed to do now. So score actually calculates the score, and roll records the rolls. So I'm quite happy with that. Now we can go back to trying to pass this test. So it fails. We got 11 instead of 12 because we don't account for the bonus of the spare. Come back here. What we're going to have to do is let's do this. This is naive and it's not actually going to work. We're going to have to go and do back more. We'll have to do more refactoring, but I'm going to write it first, and then we can see why it doesn't work. So if we have a look at our index, or if we have a look at the sum of two consecutive rolls, which is a frame essentially, and if they're equal to 10, then our score will be 10 plus the score in the next roll after the spare. However, what's happening here is we're incrementing roll index by 1 each time, so we're moving, we're not moving by a frame each time we run this code, we're moving by 1 roll, and spares are sort of they occur by frame frame by frame, so we'd have to increment roll index by 2, but it all sort of gets very messy. So I think if we have if we have a variable frame where frame is less than 10, we increment it each time. We'll also keep our roll index equals 0. Okay, so this code is going to execute 10 times, once for each frame, and we'll increment roll index by 2 each time. So each time we iterate over a frame, we increase roll index by 2 because there are two rolls per frame. And just add an else here. Our code should work. Nope, it doesn't. Expected 2 but was 1. So that's rolling 1, then 1 scores 2. So let's see what's happening here. Exactly, okay, so we should be adding the total score for a frame each time, rather than just the first roll. Okay, so this is very messy code. Time to refactor. Our code's passing, so we have permission to refactor. This method is checking, this code here is checking whether our current, the frame we're in is whether we scored a spare in it. So we'll call it is spare on our code. Test pass, so we can continue refactoring. I'm going to have a method that sort of labels this piece of code, so this is our spare bonus. And then our code still passes, and same for this. So this is so sum of rolls in frame. And I'm going to move this code into the for loop. Okay, code's passing. Quite happy with that. So we can go back to our tests and write more tests. So if you look here, we're just assigning the value of this to score. So if we score anything before, if we roll anything that isn't a spare, if we roll anything before a spare, and then have a spare, we'll just assign the score of the spare rather than accumulate all the scores. So we need to write a test to specify that behavior. So if we rolling 1, then spare, then we need another roll for the bonus. So 1 again scores 13, I do believe. So this time I'm writing my session there first. So we want to roll a 1, then okay, I'm going to write this code out now to score a spare, but after I've written this I'm going to refactor out the code to score a spare, so that for a start our test will be more descriptive, and we'll have less duplication. So if we decide that you need, I don't know, so say we have 11 pin bowling or something, or 9 pin, it will be easier to change. So we got 12 instead of 13, as I expected, and now we can add the score. Still fails. Because this test is wrong. We have to finish off our first frame. So if we throw another 1, then 14, so rolling 1, then 1, then spare, then 1 scores 14. It's not a very good name. I welcome suggestions for better names. And our test passed now. I'm just going to change that back, make sure the tests fail. So expected 14 but was 12. That's what you'd expect because you overwrite the score from these two rolls, or the first frame. So changing that back. Okay, now we can have a look at strikes. Rolling strike, then 1, then 1 scores. Okay, so with a strike, that's where you knock down all the pins in one throw and you finish that frame off. Your bonus for that is the sum of the next two rolls. So if you threw a strike and then scored, then you rolled your next ball and knocked over 1 pin, then rolled your next ball, knocked over 2 pins, your score for the strike would be 13, and your total score would be 16, as you'd get the score for the strike and the bonus from the strike, and then your 3 for the next frame. So rolling strike, then 1 scores 14. Oh, I'm just going to comment this out, make sure code still passes. Now I'm going to refactor out this code for spare. So roll a spare. Yeah. Let's see if we've got any other code that needs refactoring out. So we've got these where we're rolling multiple times. It's not particularly elegant, but we've got this code here that I think we can refactor out. Let's call that roll many. And the code, it's pointless at the moment because it rolls 1 twice and does nothing more than that, so we'll have to modularize it a little bit. So we'll roll up to n on the tests and be a number of pins we knock down each time. So now we can use that here. Many, we'll roll this twice, and we're expecting. We want to roll 1 twice. And we can use that in here as well. Okay, that's quite nice. So we can move on back to this test I was going to write, but forgot to refactor the code before doing that. So let's write our assertion. So we want to roll a strike, or score a strike, then roll 1 twice. So we get 12 instead of 14 as we're not applying the bonus. So if our so if we find that we've scored 10 in one roll, then we increment the score by 10 and by our bonus as well, which is roll index +1 plus roll index +2. Again, I've jumped the gun a bit and put an equals here, plus equals there, so I'll change it to equals and we'll write another test to specify the correct behaviour. This is going to fail because we're going to increment roll index by 2, so we're only going to add on the last one that we roll. So we'll roll this 10, and our roll index will be 0. So we'll count for that here. Once we run through this code, roll index will be 2, and we'll only catch this last one. So what we want to do here is decrement roll index to account for our shorter frame. Array out of bounds. Okay. Why? Oh, because it's not an else if. There we go. So that passes, and we can factor this code now. So, is it a strike? Run our code. And this is our strike bonus, but for some reason the refactoring menu is not working. So we're just going to do this manually. Strike bonus. So manual refactoring, you write the method that's going to replace the code, highlight the code, copy it, paste it, run your tests, and now highlight the code that you copied, replace it with your method invocation, ta-da! We've refactored this code now, and we can go back to our tests and write that test to specify the plus equals rather than equals. Rolling. So again, we'll just roll a 1, then strike, then 1, scores. Okay, so we score 2 initially, then our strike will score 12, and then we'll score 2 for the final frame. So that's 16 in total. And as you can see, we got 14 instead of a 16 because we overwrite the first frame. Okay, so that passes, and our code looks reasonable-ish. We've got this conditional inside this looping construct, so I don't know, maybe we could refactor this out. So this could be, yeah, let's do that. Let's have calculate. I want to refactor this to something called calculate score, which is very much what this method is doing. So I'm not particularly, I'm not going to refactor it out. I can't think of anything good to call, anything accurate to call it, so I'll leave it as it is for the moment. It's an exercise for you to rename it, refactor it out, and make sure the code is coherent.